Question number 20, which says treatment of alkyl chlorides with aqueous KOH leads to formation of alcohols. RX, aqueous KOH gives ROH. Okay, but in presence of alcoholic KOH, alkenes are the major products. Explain. See, this is a substitution reaction, classically, typically SN1 or SN2, and this is elimination E1 or E2. So the question is, by changing the solvent from aqueous to alcoholic, why is it that the substitution reaction actually changes to elimination reaction? Although NCERT has oversimplified this, it's a very unfortunate misconception. Let me first tell you a disclaimer. I'll explain what they want to say, etc. But this is true only for secondary alkyl halides. Properly and honestly, it is not true for primary or tertiary. It is true only for secondary. NCERT has been happy enough to generalize it to everything, and it has become a very, very popular misconception now. So I'm not going to just analyze that. I'll just say, why does this difference in solvent change the mechanism? Let me talk about that. You first need to understand the basic behavior of solvents. In aqueous solution, KOH is totally dissociated, nearly totally. That means it is present as K plus and OH minus ions. Not just that, this OH minus ion is heavily solvated. What is the meaning of solvation? It is surrounded by water molecules. Okay. So if OH minus is surrounded by water molecules because of very strong hydrogen bonds, great. Understand that this is a more polar medium. As a solvent, water is more polar. You have OH minus ions, and these OH minus ions can serve two purposes. Number one, they can act as a base, yes, and number two, they can also act as a nucleophile. Indeed. Now, just shift over to another solvent, alcoholic KOH. In alcoholic KOH, you have EtOH plus OH minus, and they form EtO minus with H2O. So actually, in alcoholic KOH, you also have alkoxide ions. Alkoxide ions are bigger and huger, right? So EtO minus is bulkier than HO minus. Obviously, ethyl group is much huge as compared to hydrogen atom. If it is bulkier, this means EtO minus is a poorer nucleophile. If it is giving SN2 attack, it is going to face more resistance because it is huge, it can't enter. OH minus is smaller, it can quickly and easily enter. So EtO minus is a poorer nucleophile than OH minus. Okay. If it is a poorer nucleophile, but both of them are good bases, across the internet I have found a statement, EtO minus is a much stronger base than OH minus. That's not correct. Their basic strengths are roughly same. Had EtO minus been a stronger, much stronger base than OH minus, then a weaker base OH minus could not have made a stronger base EtO minus. It is true that EtO minus is slightly stronger. Yes, not much. But not though, roughly they have similar basic strength, but the correct reason is sorry, that EtO minus is a much weaker nucleophile because of huge bulk. Therefore, substitution reactions with EtO minus is not encouraged, is not favored. OH minus is a strong base, yes. Is it also a strong nucleophile? Very much indeed. And please note Again, there are rumors like OH minus because of hydration or solvation becomes weak base. That is stupid. If it becomes a weak base, it also would become a weak nucleophile also. This is not correct. The correct reason is bulk. This is bulky. Attaching is difficult. Substitution is difficult for ETO minus. On the other hand, when you're talking about elimination reaction, elimination involves just taking away one H plus and running away. ETO minus is good at that. ETO minus is going to approach, steal one hydrogen atom and run away from outside. It doesn't have to go very close. It doesn't have to get attached to the molecule. So substitution with ETO minus is not favored. Therefore, elimination happens. And we get alkene OH minus. It's a good base, yes. It's a good nucleophile also, yes. So can it not give elimination? It can. But at the same time, it also tends to favor substitution simply because of its thin and slender size. It can very well go within the molecule, attack very easily and get itself attached. So it gives you a very good dose of substitution reactions as well.